In Chapter 2, we're going to be working with integers and rational numbers. We'll be multiplying, dividing, adding, and subtracting them. In 2.1, we're going to just talk about what integers are, what rational numbers are. So let's start with a whole definition for a whole number. Whole numbers are basically our counting numbers, 0, 1, 2, 3, and so forth. Integers can also be negative, so they include all of the whole numbers that are positive, all of those negative numbers, and 0. For a number to be rational, it's something that can be written as a quotient of two integers. That would also be known as being written as a fraction. An opposite. The definition of an opposite is two numbers that are the same distance from 0 on a number line, but are on opposite sides of 0. So -3 and 3 are opposites. Absolute value refers to the distance between a number A and 0 on a number line. We represent absolute value with two lines surrounding a number, a variable, etc. The important thing to remember about absolute value is that regardless of the sign inside the absolute value symbols, it's going to be positive. And a conditional statement is a statement that has a hypothesis and a conclusion, and we'll look at some examples of conditional statements at the end of this lesson. In example 1, we are going to graph and compare integers. So to graph numbers, we draw a number line, and we're going to be graphing -2 and 5. To graph -2 on a number line, we just put a point at -2 and a point at -5. And we can label them above as to what they are. And on a number line, -5 is to the left of -2, so -5 is less than -2. In example 2, we're going to be classifying numbers as whole numbers, integers, or rational numbers in this section. Okay, the number 3, yes, it is a whole number. If a number is a whole number, yes, it is also an integer, and it is rational. If you answer yes to a whole number, you're going to answer yes to all three. Now, 1.7 is not a whole number, because it has a whole and a part. But is it an integer? No, because an integer, again, has to be one of the counting numbers, but that also can be negative. Is it rational? Yes. We know this is rational because it is a decimal that has an end to it. -14, not a whole number. If it's negative, it's not going to be a whole number at all. Is it an integer? Yes. Yes, it is an integer because it is a counting number, and negatives that are counting numbers are integers. And since we answered yes to integer, we will also answer yes to rational. -1/2, not a whole number because it's not a counting number, therefore it's not an integer. But is it a rational number? Yes. It's written as a fraction, and that's pretty much the definition of what a rational number is. Now, to order rational numbers, there's a few ways we can go about this. First step that we're going to do is to put them on a number line. Okay? This is showing the low daily temperatures for a town over a 5-day period. We're going to order them from warmest to coldest. But to get them in order, we kind of want to look at them on a number line first. So on day 1 is 0 degrees. So we're going to put a dot at 0. That's day 1, which is 0. Day 2 is 10. So put a dot at 10. Day 3 is -2. Day 4 is 5 degrees. And day 5 is -7. Now, to put them in order from least to greatest, we would read them in order from left to right. That would be -7, -2, 0, 5, and 10. But to be careful, it asked for the warmest to coldest days. Well, 10 was the warmest day, and 10 was on day 2. 5 was the next one, and that was day 4. 0 was on day 1. -2 was on day 3. And -7 was on day 5. We have a checkpoint. Now would be a good time to pause it and work on it yourself and then check your answers. We are to tell whether each of the following is a whole number, an integer, a rational number, and then we will order them from least to greatest. So let's just start with 0.8. Is 0.8 a whole number? No. Is it an integer? No. Is it rational? Yes. So we'll say 0.8 is rational. Okay. -17. Is it a whole number? No, because it's negative. Is it an integer? Yes, because it is a counting number with a negative sign on it, which makes it an integer. And if it's an integer, it's a rational number. -5 3/4. Whole number? No. Integer? No, because it's not a counting number. But it is written as a fraction, so it's rational. And finally 2. 2 is a whole number. It's a positive counting number. If it's whole, it's an integer, and it's rational. To order numbers like this, the best thing that you can do is to probably put them in the form of a decimal. The only one in this list that's not in a decimal form is -5 3/4. To make it a decimal, you're going to take that -5. You don't have to do anything with that. But you take the fraction 3/4, and in your calculator you do 3 divided by 4, and you get 0.75. So it's -5.75. Then you take the other ones that are already in decimal form, and you line everything up by the decimal. You have 0.8. -17 has a decimal after it, and you can add extra zeros so that everything lines up, and then -2. Now we're ordering them from least to greatest. I'm actually going to find my greatest number first, just so I can stop looking at it. The only number here that's positive is 0.8, so it's actually going to be the last one that I list. It's going to be the biggest. Now, when the smaller a negative number is, has to do with the whole number in front of it. So the bigger the number, 17, with a negative sign in front of it, makes it the smallest number. So -17 is going to go first, then -5.75, then -2. And these are ordered from least to greatest. In example 4, we're going to find opposites. Well, if A is -4.8, we say its opposite is -8. That means that it's the negative of -4.8. Those negatives cancel each other out into a positive. So the opposite of -4.8 is a positive 4.8. And if we want to do B, A is 5/6. Negative A is its opposite, and that would make it -5/6. To find absolute value, we're going to learn the notation that's associated with absolute value and what it means. If x is a positive number, so whatever's inside the absolute value symbols is positive, then it's still just equal to x. It doesn't change it, it's just always going to be positive outside. If x is 0, the absolute value of 0 is 0. And if x is a negative number, whatever is inside will be the opposite. This can be a little misleading, so we'll be careful with this notation right here when we actually apply it. So the absolute value of 5 is just simply 5. The absolute value of 0 is simply 0. The absolute value of negative 4 is the opposite of negative 4, or just simply a positive 4. In example 5, we're going to find the absolute value of some numbers. So a is negative 3/7. So we're going to start by putting this into absolute value notation. Should be a straight line. So that would be the opposite of negative 3/7, which is a positive 3/7. And in B, the a is 2.9. The absolute value of a would be the absolute value of 2.9, which is simply 2.9. And in example 6, we're going to analyze a conditional statement. We're going to identify the hypothesis and conclusion of the statement that's given. The hypothesis always comes after the if a number is an integer. So the hypothesis is a number is an integer. The conclusion is the then. Then the number is positive. This statement, however, is false. A counterexample is an example that proves that this is not true. So, for example, negative 5 is an integer. But it's not positive. And you may have to do that. You're telling the hypothesis and conclusion of a conditional statement, but you're giving an example of when it's not true. If it's always true, then you would just say it's true. So in our checkpoint, we're going to find two things for A. We're going to find its opposite, which is denoted with this as opposite, and its absolute value. So the opposite of 6 is negative 6. The absolute value of 6 is 6. For number 3, if A is negative 9.5, its opposite is a positive 9.5, and its absolute value is a positive 9.5. And for 4, the opposite of negative 3/8 is a positive 3/8, and its absolute value is also a positive 3/8. And one more checkpoint for this section, and that is identifying the hypothesis and conclusion of the statement, telling whether it's true or false, and if it is false, giving a counterexample. So let's start with the hypothesis. If a number is negative, so we look for the if to find our hypothesis. A number is negative. The conclusion then the absolute value of the number is negative. So the conclusion is the absolute value of the number is negative. Is the statement true or false? It's false. A counterexample that we could give is that negative 3 is negative, but its absolute value is equal to a positive 3. The absolute value of a number is never negative. It is always going to be positive. And that should read, but its absolute value is negative 3. That concludes section 2.1.